Alright, what up? This is Mr. Shakar, and I got a sick child, so I'm teaching this lesson late at night, and because I'm working the midnight hour, kind of like Santa Claus, about to give you this problem. So the first thing that we're going to begin with is, we're going to begin with some of these problems here. Like I got letter A, I'm looking at x plus 9 is equal to 3. Oh, I'm so sorry. One of the things I should have talked about was the fact that we are going to be solving algebraic equations in one step. So we're doing one-step algebraic equations. In case you were wondering, like a bouse, this is chapter 2.2 of algebra. So I'm ready to do this. So the first one we're looking at is something plus 9 is equal to 3. So like some really basic stuff, you could actually work that backwards and guess and check, and you'd be like, I don't know, 15 plus 9? No, that's not it. So we could mess around a lot. But here's the key that I would like you to get out of this. What we can do is we can do inverse operations. What? Inverse operations. So the way that inverse operations is that you go ahead and you work some stuff backwards like a bouse. Okay, so here we go. The first thing I'm gonna do is gonna do the opposite of adding 9. What's the opposite of adding 9? Well, I think it's subtracting 9. So I'm gonna subtract 9 from both sides. Now when I subtract 9 from both sides, 9 minus 9 cancels itself out. And so that disappears, and I'm left with x is equal to whatever 3 minus 9 is. Okay? So 3 minus 9 would get me down to, that's right, neg 6. Okay? So we'd be at negative 6. Are we cool there? So 3 minus 9 would give me negative 6. If you're not really sure how that works, you can work with like a number line, and you can start off at like, here's 0, here's like 1, 2, 3. All right, and if I was gonna go back 9, I'd be like 1, 2, 3, 4, 5, 6, 7, 8, 9. That'd be negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, like a mouse. So that'd be the idea. All right, cool, so let's keep this going. Remember, the key to this is inverse operation, and I want to see the work. 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 All right, so I'm showing the work here in that I would be going subtracting 9 when it's adding it. So the next one we have letter B, and letter B in this case is x minus 2 is equal to 11. So an x minus 2 is equal to 11. Again, you could guess and check, but I'm not really interested in that. I want you to know, not guess. Show your work. So here we go in this case. What I'm going to do is I'm going to go ahead and what's the opposite of subtracting 2? What's the inverse operation of subtracting 2? Well, it's adding 2. That's right. So we're going to go ahead and we're going to add 2. So I got x plus 2 here. All right. And I'm going to add 2 over here. And that's called the addition property of equality, because you've got to do it to one side, you're going to do it to the other. Once again, addition property of equality, add to one side, you're going to add to the other. The negative 2 plus 2 cancels itself out. I'm left with x. This x over here is equal to 11 plus 2, which is 13. Very nice. Okay? So here we had addition property of equality. We added the same thing to both sides of the equal sign. Back up here on letter A, we subtracted 9 on both sides of the equal sign. And in that case, that is the subtraction property of equality. All right, so I'm kind of losing my Santa hat. All right, now check out on example C. All right, because the answer is always C, like a mouse. All right, this is losing. We now are gonna do this guy. I have negative 4x is equal to negative 28. So check this out. When you're looking at negative 4 next to x, the implication is that these two bad boys are multiplying. So to do an inverse operation of negative 4 times x, we're going to divide. So the inverse of multiplication is division, and that's what we're going to do. So I'm going to divide by negative 4. All right, not just 4, but I got to divide by, you said it, negative 4. Good. And I'm going to do it to both sides. I'm going to divide both sides by negative 4. Okay, so negative 4 divided by negative 4, these two cancel out, become 1. All right, so I have 1x here now. All right, these two cancel out. They don't become 0, because then it'll be 0 times x. All right, that's not what we want to do. They cancel out to be 1. All right, now a negative 28 divided by a negative 4. Now a negative divided by negative is a positive. You're totally correct. Okay, so now I'm going to get a positive because dub negs is going to give me a positive. And in that case, I'm going to end up with positive 7 because 28 divided by 4 is 7. Cool on that? Good. Let's move to the next one. Up here I got letter D. All right, so in this one, we have x over 3 is equal to 7. Now, x over 3 implies it's dividing. X divided by 3 is equal to 7. Well, what we're going to have to do to solve that one is we have to do the opposite of dividing by 3, which is multiplying by 3. That looks good right there. I'm looking good. All right, so we're going to be multiplying by 3 in this case. Okay, so I'm going to move this D over here, and we are going to multiply by 3 on both sides because this is the multiplication multiplicative property of equality. Sorry about that brain fart there. All right, so when you have multiplying by 3 and dividing by 3 happening on the same side, these two cancel because they're both equal to 1. So I'm left with x over here, all right? And then we have 7 times 3, which is going to give me a 21. So the value of x is equal to 21. I could check it and be like 21 divided by 3 is 7. Oh, it's equal to 7. What do you know? All right, cool. So then the very last one I'm going to do is here. I'm looking at negative 3/5 x is equal to 9. All right, so here's the deal. This is where guessing and checking gets a little sketch. But you could do it, but I don't recommend it because we're about to get harder and harder in these processes. And so I want to make sure that the process that you use always works as opposed to kind of flip-flopping and only working some of the time. So one of the things I'm going to do is I'm going to move that E over here to give us a little more space. All right, so now I'm going to be in this problem, I've got negative 3/5 multiplying times x is equal to a positive 9. So what we've been doing in the past in these previous examples is that I do the inverse operation. So what is the opposite of multiplication? Not so much opposite, but the inverse process. And that's division. Division is the inverse process of multiplication. So what am I going to do? Well, what I'm going to do is I'm going to divide by 3/5. But wait a second, how do I divide fractions? Ah, man. I think the way I divide fractions is I multiply the reciprocal. So flip the reciprocal. We're going to go ahead and multiply the reciprocal over here. So the problem initially was negative 3/5 x is equal to 9. Well, we got to keep this negative still, but I'm going to be multiplying it by, and what's the reciprocal of 3/5 or negative 3/5? Well, it's negative 5/3. Oh, and I have to do the same over here because it's the multiplicative property of equality, right? So I hope you remember that. So dividing fractions is you multiply the reciprocal when dividing fractions. So here we go. I can cross cancel stuff because I can do that kind of thing. And 5 goes into 5 one time, and that's going to be like a negative 1. And then I have 3 goes into 3 one time. Oh, and then we have negative 1 times negative 1, which is going to be a positive 1. So basically I just end up with positive 1x. Oh, there's my x. All right. And then over here on this side, I'm looking at 9 times negative 5/3. I wonder if I could cross cancel anything. I think I can. So I'm going to cross cancel. I say, hey, I'm going to put 9 over 1. And I say, is there a number that goes in both 3 and 9? Yes, it's 3. And I say, how many 3's are in 3? Well, there's one of them. How many 3's are in 9? Oh, there's 3 of them. And now I multiply what I have left. What's 3 times negative 5? Oh, it's negative 15. And what's 1 times 1? Oh, it's 1. So basically, I get down to an answer of x is equal to negative 15. All right? No, basically, that's it. X is equal to negative 15 because anything over 1 is itself. All right. Taking it back just a step over here, back to letter C. I may catch some heat on this one from some people, so let me just explain this real quick. When the answer was correct, but there's just another way you can consider it. If I'm looking at this and I have my negative 4x, another thing I could consider doing here, I said divide by 4. I said divide by 4, or negative 4. I should get myself straight. I said divide by negative 4. But something some people do is this. What they do, I'm going to put the C over here. What they do is instead of dividing by 4, they multiply by 1/4. Because dividing by 4 and multiplying by 1/4 is the same. But let me just get that straight with these being negatives. So I could divide by negative 4, or I could multiply by neg 1/4. This also will cancel it out. And over here, I could also multiply by neg 1/4. Okay? So, again, these would cross cancel, in which we'd end up with only x. And in this one, we'd end up with positive 7 still. It would still come out to be the same answer, but there's just a little bit different way of showing that. So I just wanted to make sure I cover my bases so that if you see it either multiplying the fraction or dividing the integer, either of those will work out for you. Anyway, really sorry I can't be in class tomorrow. I came out here. It's like 9:58 at night, but I'm just trying to make sure you guys get your lessons and stuff like that. Super excited to see you guys again on Tuesday. Peace and take care. All right, bye.